Hi, this is Tosho Hirasawa, here present our work on kitchens and unedited overhead view video dataset as a vision language benchmark. Procedural video understanding is a fundamental technology for skill transfer. With advances in vision language foundation models, the field of procedural video understanding has gained significant attention, resulting in the creation of numerous datasets. These datasets are typically sourced from the web or egocentric videos. Our study focuses on fixed viewpoint observation, a prevalent but relatively unexplored format in procedural video understanding. Modern smartphones equipped with well-calibrated wide-angle cameras can capture extensive work areas from an overhead view, presenting new application possibilities. We aim to investigate the domain gaps between fixed viewpoint videos and those captured from web or egocentric perspectives to guide the development of future skill transfer applications on smartphones. These domain gaps include editing versus non-editing. Fixed viewpoint videos are generally non-edited, focused versus unfocused events. Egocentric videos typically have event-focused frames. We utilize the iPhone 11 Pro to collect video data, providing these devices to participants who then recorded their cooking activities following specific recipes. In total, we gathered 213 valid videos featuring 84 different home kitchens and 1970 unique recipes. Each video averages around 16 minutes in length. One of the standout features of our dataset is its high environmental and task diversity, with recordings from numerous different kitchens and a wide variety of recipes. Among 213 valid videos, we annotated visual action graphs for 145 videos, totaling 40 hours of footage. A visual action graph tracks ingredients and the actions performed on them. Bounding boxes show each ingredient's visual state before and after each action. It also gives the duration of the action. The action is also tied with the recipe text, linking vision and language with rich task context. For example, the action of adding shredded dried squid starts from the frame with red bounding box and ends at the green bounding box. When an ingredient first appears in the video, its name is tagged to the corresponding bounding box. A destination bounding box is used to represent mixed ingredients. With action graph annotation, many unexplored tasks can be tackled, such as visual action graph estimation from video and text inputs. Among them, we have chosen one that directly enables new applications for online recipe recognition and navigation, which we call online recipe retrieval. In this task, the query is based on visual observation. Unlike traditional cross-modal retrieval tasks, the query video in this task ends in the middle of the workflow. This forces the retrieval model to work at any point within the workflow. In other words, it must work online. The task has two retrieval targets: feasible recipe and the current stage of the recipe. Feasible recipe is one that the chef in the video can switch from the original recipe immediately without needing any modifications to the processed ingredients. The current stage of the recipe refers to the progress in the workflow. Our experiments have confirmed that current state-of-the-art cross-modal retrieval models cannot solve this task effectively. Therefore, new techniques need to be developed to address this challenge. The second benchmark task is dense video captioning. This is a traditional task, but our target videos exhibit significant domain gaps from web videos, since ours are unedited overhead view videos. More specifically, the domain gaps arise due to several reasons. First, repetitive motions. Unedited videos often contain repetitive motions, which are typically omitted in edited web videos. Second, lack of focus on active objects. The frames in our videos do not focus on active objects and events due to a fixed camera perspective, whereas web and egocentric videos tend to zoom in or centering on such details. Third, length of videos. The video length is considerably long in our dataset, averaging 16 minutes, compared to much shorter durations in web-based and egocentric datasets. These factors make traditional dense video captioning, or DVC, very challenging on our datasets. We invite researchers to tackle these benchmark tasks. Thank you for listening.